ISOC people are coming in. We can start now. 2 o'clock. It is 2 o'clock. You're on. Cue the mic.
All right. Slides. You're progressing him?
Oh, you want? Well, actually, I should because it goes first. Yeah.
Okay. Sure. So, welcome to Lurk. Thanks everyone for coming. We'll start with a note which everyone should have seen by now, and we're all bound by it. I would like to remind you that there are actual IPR statements around some of this work, so the note does in fact apply. Next. Our goals for today is not, so the BOF today is not working group forming, not yet. We would like to explore together the scope of what we'd like to do and how it could boil down into an actual charter. And we'll spend a lot of time on potential solutions for the problem that we're trying to understand today. So both the problem, the exact use cases, the exact things we want to address, and of course the technical solutions are still open, still very much a subject for discussion. We've had a very extensive discussion on the mailing list so far. We have a good number of internet drafts, but we expect a lot more discussion in the room and following this meeting on the mailing list. So we have this introduction to fill up 5 minutes. Then Rich will discuss the problem that we're trying to address, followed by 4 presentations on the solution space, and then an open-ended discussion about the solutions that were presented. We will finish with a short charter discussion, basically to understand whether we're converging towards one well-defined charter from which we can create a working group. Everybody in the room, if you're still not on the mailing list, please make sure to join the Lurk mailing list. It's been quite busy, and I hope to continue to have a very good discussion on the list. And with that, Rich.
Don't worry, this is coming out of my time, not your time.
That's okay. Yeah, no problem. Those are cool.
Yeah, so you don't have to look backwards.
It's a hard habit to break. Okay, next slide. Okay, so the problem statement is The problem statement is basically how can I let others use my key or the key that identifies me without risking long-term exposure? Question is, why do you want to do this? We have one agreed upon use case, or one that got wide acceptance on the mailing list so far, which is content delivery network. I have a website that's got a long and noble history, FIFA.org, and they want to distribute their content globally through a CDN, and they don't want to give that private key to the CDN because they don't trust them. Right? So two organizations is trustworthy then. So that's one. So that's the major agreed upon use case. There have others that have been proposed on the mailing list. None got a lot of uptake or interest so far. I thought code signing, and that's just my opinion, was one of the more interesting ones. Speaking with one of the Debian maintainers, DKG, it's probably not of use to them because they'll just re-sign PGP things that are already signed. So we're still, I think, looking for more use cases, but perhaps the CDN one is enough to focus on first, and certainly focuses the discussion. It might have some impact on what we provide in the protocols, or limit it, or it might just be a good first case. So I think we're looking for others. Next. CDNs. So the origin, the content provider, contracts with one or more CDNs. In the large case, they all contract with multiple CDNs. To provide a better user experience, CDNs work by replicating and caching the original content or transforming it or providing original content on behalf of the original organization, on behalf of FIFA. The CDN may, for example, calculate the postal scores or the bidding price on the next location, whatever it is. Or it may be static content. They terminate TLS from the end user's browser or client. It's this case, in this situation, they replicate the private key. Depending on how the CDN works, it may be a couple in the country, it may be a couple of dozen in the world, it may be thousands. It all depends on the CDN model. And sometimes these are in hostile areas. Hostile meaning a place that could, by law or surreptitious methods, force you to disclose the key. There, Virginia, other parts of the world. Other use cases to be determined on the mailing list. Next, there are two approaches that seem to be common or suggested to have come up so far, not to close off the discussion by any means. One is this one, where you have the browser, a classic Netscape Navigator talking to a server. There might be multiple instances of that server. Say, for example, it's the front-end reverse proxy and the CDN, and they all go back to the origin. All right. Okay. Now I can hear it too. Okay, so many approaches use this architecture. Browser to server to origin. The idea being that between the server and the origin, there is some protocol, a Lurk protocol, that would handle the key usage. Next. Approach 2 has come up a little bit. Time limit the certificate and key pair. That doesn't address some use cases. For example, code signing wouldn't necessarily work this way, but for a CDN or online use, the idea that you issue, a one-day key and replicate that across the edge of the CDNs. Next. That's it. Okay. So it's sort of a summary of what's happened on the mailing list so far. Any questions? Otherwise, we can move on.
So, yeah, a quick on-the-fly change.
Surprise.
Yeah. Rich, could you go to your next slide deck, please?
Sure.
Followed then by Daniel. Sorry, Daniel.
No problem. Okay. So this is a proposal we're making. Samuel Erb at Akamai wrote a lot of the initial text. I feed it into form. RSA LG is not a typo, even though my fingers always made it a Z. Next slide, please. Okay, so in terminology, I think it's particularly important that the working group, whatever we're going to be, figures out the terms for the players that are involved. There's an old from the Harris's Lament, all the good names are taken. So we're using this set of terms here. Also showed up on the previous slide. I don't care what they are. So we have the client, who is the one initiating the request, the server who is providing the TLS termination, and then the key owner, who may or may not be the content provider, right? So who's the site that's got the content may be completely disparate. So that's the one running the web server. The key owner is the one running the other side of the Lurk protocol. So our preference is just let's pick terms and stick to them. Next. So our goals in this protocol are we don't want to be a signing oracle. We don't want to be, if I can have a semi-open server or a server widely accessible, pardon me, I don't want to take any content that's provided to me and sign it. Because that can later on be used to deconstruct things. It can be used in cross-protocol attacks and so on. We also want to provide stronger protection for session encryption keys or tickets. Talk about details on both of these in a bit. And we don't want to lose perfect forward secrecy. If the key owner is compromised or either side is compromised, previous sessions aren't susceptible in the face of national scale adversaries scooping up all the traffic so they can decrypt it later. We don't want to make their job easier. So protocol overview, there is a draft published just before the deadline, like they all are. We use the TLS presentation syntax. I'm not sure if it's presentation, but the TLS notation. It's a request response protocol. There's an ID in every request. The response echoes back the request ID. It's just a number. I think it's 32 and 32. That allows streaming, pipelining into out of order responses and so on. The connections between the server and the key owner should, perhaps must, be mutually authenticated TLS. So the key pair used mutually authenticated, so the server has a key, strong crypto, PFS, all of those kind of things. We're not leaking key material, or we're not sending any kind of real key material over this, outside of some session key. But we want, for various other reasons, we just want to make sure best practices on that. So the static RSA details. This is the RSA LG. It's kind of like DH. The server picks a number n, and it uses the hash of that as its server random. So it sends the the digest SHA-256 back to the original client as its random. But it sends n, the full number, original number, to the key string to the key owner server. The key owner, when it's generating the PRF, and this is clearly TLS1.2 because we use PRF, uses SHA-256, the same digest in its calculation. Right? So it's going to repeat what the client would repeat. But what that does is that means if someone has intercepted the traffic, unless they've also intercepted the original N, which is ephemeral and thrown away, they can't deconstruct what the PRF is going to be. Right? So future access to the key owner protects traffic since the adversary needs N and not the digest of N. N is very ephemeral. After the handshake, as soon as the handshake completes, or as soon as the server side of the handshake is done, you throw away the original N. Next slide. Session encryption details. We add a hash of the private key into the KDF. Part of the reason for doing that is so that if you're serving multiple, if a single process is serving multiple key owners, key owner A can't attack the sessions of key owner B because the SHA of the other guy's key is mixed in. The server sends a salt, which the key owner uses to generate unique sessions. And there's also a string mixed in there with the HMAC, so that the session keys are unique for only session keys. Right? You can't take a key and use it elsewhere, or find a key and use it for this. Next. Okay, so the next steps, if the working group is created and the working group adopts this draft, then there are things that make sense to add. We just want to provide almost a proof of concept of this. ECC variants make a lot of sense. Support for TLS and other, there's probably some things we can do in the non-static key exchange stuff that makes sense. We're certainly open to, whatever the community thinks makes sense. We have an IPR on this. Crypto, fortunately, is a minefield, royalty-free with cross-licensing, right? We have other IP in this area. If the working group wants to proceed in those directions, we'll disclose and probably make much of this, I'm not a lawyer. I don't speak for my employer, but our intent is to make a lot of this stuff royalty-free, cross-licensed. I should also mention, it's not on the slides. In the interim, there's been some interesting feedback on the mailing list. I've tried to respond to some of it. There is a GitHub repo. So if you go to GitHub, Rich Sauls /draft or Lurk. But anyhow, if you go to GitHub Rich Sauls, you'll see the repository that has this, the separate pull request that added session tickets and various other minor wording changes. And turn that over into an IETF repo. As I said, if it gets adopted and move forward. Okay, and that's it.
Yeah, Rich, one quick question. The last bullet on the slide is a bit worrying, so I wanted to make sure there is one single IPR statement file. As far as you know, there is no IP that you're aware of that applies to any of the other proposals that we've seen?
Not from us. And also the disclosure we filed allows complete implementation of what we've documented so far. Pardon me? Yeah, of course. Yeah, I can't speak for anybody else.
Yeah. Oh, yeah. Yeah. So today I'm going to talk about TLS authentication with Lurk. We're going to see how Lurk is changing a little bit the way authentication is proceed in the standard TLS. So we're going to look at two different authentication methods, RSA, CDHE, and then I'm going to provide some first straw man on the protocol Lurk itself. There's many questions. So the big difference with Lurk compared to the standard TLS is that the TLS server is actually split into two different functions. One which I call here the edge server, so that the server terminating the TLS connection, and the key server that is owning the private key. So what we were talking about is only the authentication method used, which is represented in red in the slides. So there are a few authentication methods provided by TLS, and so far what I noticed from the mailing is that ECDHE and RSA as a main authentication method people are interested in. Mostly RSA for backward compatibility, and ECDHA because it's where we should go. So let's go with the RSA model. So the idea is that the edge server is providing the encrypted premaster, eventually with other parameters, to the key server, and the key server is sending back the premaster in clear text or the master secret or the extended master secret. So the first thing we can notice is that all of the input parameters provided by the edge server to the key server are parameters that have already been exchanged and transmitted between the web server and the edge server on the wire. This is not the case for the output, because the pre-master is, well, in the standard TLS is computed on both sides and is never transmitted over the wire. So this is something that is changed here. And this is why we probably need well, a confidential channel between the edge server and the key server. But the other thing that is pretty much different from the standard TLS is that the key server, well, if when the TLS server is performing the authentication, it is aware that the client is initiating a TLS connection. This is not the case with the key server, because he has no way to see if the request for decryption is coming from a client or something else. So one way to mitigate a little bit that is to, well, we can provide a little bit more context to the key server, or make the output provided by the key server unusable outside of the establishment of a TLS session connection. So this is why I would recommend that we don't send the pre-master secret, otherwise we fall down into an decryption oracle, but rather sending the master secret or the extended master secret, so that you provide a hash, and in that sense you make, well, outside of a TLS establishment, it's rather useless to perform a cipher text attack, for example. So now let's go to ECDHA. So with ECDHA, well, the idea is that authentication from the server is done by signing the ECDHA parameters, or eventually the hash. Oh yeah, okay. So yeah, and you send back the signature. So same thing, all the input parameters provided by the edge server have already been transmitted in clear text between the edge server and the web browser. So there is no real leak of information in that sense. On the other side, well, the signature, same, is going to be transmitted. So although, well, the channel should be authenticated, there is no disclosure of sensitive information in that case. Similarly, in order to avoid to make Lurk a signing oracle, well, because the signature is performed on the hash, or you can provide all the inputs. To reduce the scope, it might be better to provide all the inputs to the key server rather than only the hash. So this would be my recommendation about the inputs. I'll provide the client a server random as well as the PRF or the hash function, and then wait for the signature. Now, what about the signature itself? I suggest that we consider what is being done in TLS 103, so providing some structure where you provide the algorithm and then the value. I'm looking at Eric. Maybe I'm saying something bad. This is
from 1.2.
okay, because it was not clear whether the algorithm was specifying that.
It was a different, the structure was packed differently.
Yeah.
Keep going.
So that's, well, for the signature, when we use RSA, I would think of using RSA, well, PSS, instead of the one using TLS 1.2.
I mean, isn't the whole principle of this entire operation that unmodified clients can talk to your server?
Sorry?
Isn't the entire principle of this entire BOF that unmodified clients can talk to you, the collection of the edge server and the key server?
So I'm not sure I do understand the question.
So again, like nobody supports PSS, and so the consequence in TLS 1.2, and so the consequence is, and since the whole point of this thing is to allow the existing clients to talk to the complex of things in the back end, you must generate a TLS transcript which is conformant to what clients currently expect, or it won't work.
Well, that's between the edge server and the key server only. So then you might have a conversion, a format conversion.
Can't convert
Oh, we
PSS to PKSS1.
Okay.
Certainly, I would be very surprised to learn that you could.
Okay. So then we need to have the two formats.
But I guess I'm trying to figure out this point Rich made of being a signing oracle, right? Supplying the information to the I mean, in 1.2, right? The data that is signed is essentially the client random, the server random, followed by the public key, right?
Yeah.
So what are you expecting the server to? So say I supply those values to the server, to the signing server. What are you expecting it to do with them?
What do I expect to do?
Yes. How do you expect it to validate that it's not being asked to sign some entirely random message that is approximately 64 plus 128, bytes long?
But so that what are the mechanisms we provide so that it not become a signing oracle? Is that the question, or?
Yes.
So, well, providing all the inputs, the different randoms.
But those inputs are unverifiable.
Yeah, but well,
Except for the
separate
server
fields,
random, right?
separate fields, and then you.
But they have to be concatenated into one block so they can be digested, right?
Yeah, but we don't. Well, yeah, but it performs the digest itself. The key server is going to perform the digest.
Right. So the signing oracle is limited only to signing messages,
Yeah.
which are exactly 128 plus 64 bytes long, right? Oh,
Yeah.
928 is longer than that. It's 256 plus. I mean, that is an extremely powerful oracle.
Yeah, maybe we can do better.
Well, I'm asking how you intend to do better.
That would have been my question.
Oh, okay. I don't know. That's part of my problem, right?
Yeah,
I mean,
it is.
I mean, purely off the top of my head, maybe you could require the server to demonstrate proof of possession of a corresponding Diffie-Hellman private value to the public value, but I'm not sure. Like, it would be expensive, and I'm not sure it would work. So, I mean, I guess my point is that the edge server has an enormous amount of control over what ciphers are nominally negotiated, and that allows them to produce like apparent messages of like a wide variety of control, right? So I mean, the only piece of information that, given the point of this, is typically to offload the Diffie-Hellman computation. I mean, unless you want to do Diffie-Hellman on the back end, right? You want to do Diffie-Hellman on the front end, then the signing then the edge server has to generate the Diffie-Hellman public key, right?
Yeah.
And yeah, I'm just having a lot of trouble understanding like how this is gonna work out, that you don't end up becoming a generic signing oracle.
But would you prefer if you have ECDHA parameters provided by the key server then?
Well, I mean, but then I suppose you could do that. You could do all the computation on the back end, and have it more RSA. I'm just saying, like, if you're going to do a signature like this, then there's like not a signing oracle, and it's just like I just send back like my Diffie-Hellman ephemeral private key and a signed block.
Okay, so before we fix this right now, what I'd like to do, because we do have 25 minutes for like deeper discussion, and also then we'll also have heard all the others. So I'm not saying we shouldn't be talking about this, but stuff like, hey, isn't the browser supposed to be unmodified, would be a good thing to ask. The details of what he's thinking, let's hold off on
Okay, but I guess I'm trying to get to the feasibility of this problem statement, and not be a signing oracle seems like a key point of feasibility, yes or no, right? And so my question is, does someone have a plausible answer to how not to be a signing oracle or not?
And that is captured in the minutes? Yes, minute takers? Yes? Okay. Go on, Damon.
So, so now that we've seen a little bit of the authentication, the differences between the two models, this is how this is a straw man for the protocol itself. So, to design the Lurk protocol, we would like to have something that is only a very small set, minimal set of authentication methods, and this to be extended with the other authentication methods. So, yeah. So, and there is no. It doesn't seem that there is any incompatibility with one of the authentication methods that are existing now. So, it can only be extended when we want. But what we would like to avoid is to have something that is supporting everything, and if no one is really using them. So, next slide. So there are different type of exchange. Some of them are the cryptographic oriented exchange, so these are the one we just talked about. But we need some additional exchanges, such as listing the capabilities of the key server, some keep alive messages, and maybe some extra information provided by the key server to the edge server in case we notice something is going wrong or bad, or we have to define how far we have to go. These are, well, the parameters we expect to be provided for a Lurk request from the Lurk client to the Lurk server. So most of these parameters have been described before. Well, looking at the different drafts, we saw that we have more or less the same parameters, so that's a good sign, a good conversion sign. Then about the output, well, in addition to those we discussed during the cryptographic exchanges, we need to introduce also some errors. So what kind of errors should we consider? Maybe incoherences between the different parameters. For example, if you use RSA and you ask for a signature, it doesn't really make sense. So these are some part of the errors that are written by Lurk. Unsupported inputs, for example, if you ask PSK, well, you don't support PSK, you have to say, I'm not supporting PSK. But what should be avoided is during the cryptographic operations to report some errors regarding those. So it should be logged, whatever. But if there is an alarm, maybe that's outside Lurk and the scope of dots, for example. Now, what about the implementation? So we talked about the Lurk at the Lurk layer, which is the application, but we need to have some kind of transport to transport these packets. Currently, we have some proof of concept implementations that are based on HTTP JSON. We can use Tibor, but there are some huge questions about which transport layer we should consider. So that's still work to be done. And then should we use JSON or should we have a very specific format similar to those used with TLS, for example? That's an open question. So these are the drafts we've currently written, one with the use case. The requirement or more an analysis between the differences with Lurk and the standard TLS. We have an architecture document with a first implementation, and we have abstract API, which is not an abstract API, but a post-roman of the protocol. So any comments on the mailing is so welcome, and thank you for listening. Comments or questions?
Hi, this is Oscar González, Telefónica. Just a comment that we made an implementation based on the draft that I think it's draft games. So it's an open source implementation. I hope there is no IPR behind that one. I mean, it was the one that was available before coming to the box. So yes, I encourage that it's an implementation of a key server. So some of the questions or some of the issues that people may have. I think it's a good thing to take it, to test it, to hack it, and to see all the issues that we raise, that if we get something, what happens with it. So we have some running code, and I think it's always nice to test it. I mean, it's not intended to be something that is performance, it is functional implementation, but I think, yeah, I hope it's good for the people interested in Lurk to use it. So it's already on the mailing list.
Okay, so thank you for sharing this implementation, and I think it would be very useful to do some measurements, especially to test the transport layers.
Yeah, so actually we're going to say thank you for ending on time early, which will give us even more time for having a good deep discussion that clearly some people would like to have. So with that, we are Philip.
Yeah, I'm sorry about the line numbers on the. It turns out it does have line numbers. You just can't see them because they're right on right. Okay, so I'm going to talk about the implementation that I did. I mean, this is the first time I've come to a BOF where we aren't too sure what the use case is, but we've actually got two independent implementations. So I discovered two sets of use cases, mine and everybody else's. Mine are mostly due to my experience of being a CA and where people screw up, which is mostly losing control of the private key. There's a particular problem on Linux and OS X in that the keys are generally stored unencrypted in a flat file. So the private keys tend to leak in backups, they get copied around and bad things happen. And the thing that is really hurting us most of all right now is software signing, in that quite often you find that in a corporation, the big ones will have one hardware security module or whatever that is a signing key. A lot of them, they have a flat file that is copied from one developer to another. And so these leak. And the final one is, this is basically an HSM interface, or as I'll get into, maybe it's a wrapper around an HSM. Maybe you have something like a Raspberry Pi that is has an HSM plugged into it, and then the Raspberry Pi around it is checking to make sure that the uses of that HSM accord with some site local policies, and that you're not using that key for other purposes. So, CDN, I'm not too convinced by this particular example. I think that short-lived certs will probably be the thing, but I have considered CDN as a possible use case. So my approach is, I see this type of work as being a natural complement to ACME. ACME is allowing you to get your short-lived certs, and so I've designed a protocol that basically follows ACME-type tropes. It's written in, it uses JSON, it's layered over HTTP, the layering is extremely similar. It uses JSON as the mandatory to intra-op encoding, but you can also drop in other encodings. If you want to do CBOR or JSON-B or JSON-C, you could do that as well. Where that might be really important actually is that in the data center case, if I have a HSM here and I've hooked up my rack to my HSM on the local net, I probably don't want to be talking TCP. I probably want to be talking UDP to that resource because I probably don't want the latency of startup or whatever. Another piece that I've inherited from my work on the mesh, oh, and sorry, I'm not sure exactly whether the room is on this floor or the 5th floor. If you're coming to my BOF at 7, I'm checking up on that. I've been given conflicting info. So another thing that I've pulled in from there is using fingerprints to identify keys, because the hash of a key is not going to change. And I just use the scheme that I came up with for the mesh. Okay, so first thing you do when you want to talk to a remote key server is you do a hello transaction, unless you're just going to do the vanilla mandatory based stuff. You don't need to. And this is where you're going to give the protocol version, and you'll get back a list of service instances, and those could be specifying different locations, different protocol bindings. You might have UDP instead of HTTP. You might do it over core, you might do it CBOR, whatever. And the authentication mechanism. You guys are thinking of doing authentication to this Lurk service, I hope. And request, well, this is just one of the requests in the spec. Yeah, I mean, like, throw a bunch of JSON over the wire, and that comes a piece of JSON telling you what encodings you have. You know, all fairly vanilla stuff. What I've not put into the code right now is the stuff that I would normally wrap that with, which is authentication and encryption in the HTTP payload. And I'll come to that in a second. Step one in your protocol, okay, we're going to create a key pair. And this is where you specify the algorithm, the cryptographic features, i.e., is this key going to be a signing key? Is it going to be an encryption key? Is it going to be a key agreement? So the HSM's got to know that. And then in addition, you might have restrictions on the operations. So you might restrict it to only TLS key exchange. I'm seeing that as something that is an extensible list of restrictions that are going to be an IANA registry at some point. I mean, like, you're not just going to tie this particular protocol to TLS. I mean, if you're going to tie it, you would tie it to TLS 1.2 using a particular key exchange for a particular set of algorithms, using a particular set of cryptographic games. I'm also looking, in my design, I also was wanting to make it possible to use more advanced crypto than we've traditionally used in IETF protocols. In IETF protocols, we've not used techniques like key splitting, proxy re-encryption, and all the great and wonderful games that you can now play now that we're moving to the Diffie-Hellman world and the elliptic curve world. And there's some really cool crypto that I want to be able to do with these remote keys. So for example, people in the previous discussion, we were talking about the key is going to live in this server instead of this rack. Well, what if you want it in both places? What if you want one bit of the server here and one bit of the server in the remote, one bit of the key in the remote server? That's another game that Lurk can support. And I would like to have the capability of doing that, and it's fairly easy to layer in with JSON, etc. Step two, request a key use. Well, for this, the request, at the very least, you've got to authenticate the request. And the response, obviously, I hope you're going to encrypt the response. And you probably want to authenticate as well. I'm just authenticating and encrypting both ways. And you're going to use TLS, obviously. I think that for something like this, I also want to have in-protocol encryption as well. So I'm using 2 layers of encryption. And finally, you've got to have an operation to dispose of the key, and it's got to be in the protocol. So the current status is I have a draft, I have an implementation. The implementation's in C#, it's up on GitHub, it's under an MIT license, and if you look at the 02 version of the draft I submitted yesterday, it's got all the links and so on. That implementation was written in 3 days. And that's because I've got a set of tools that allow me to generate specifications like this very quickly now. That does most of what I want to do in this particular spec. The current restrictions are I'm only doing RSA. I'm not doing the Diffie-Hellman or elliptic curve Diffie-Hellman yet. And I've only enabled the JSON encodings. The reason for that is that I've not documented how to use ASN1 or how to use XML, how to convert from the schema that I did. And it is a prototype implementation, so I just delete all the keys when the server shuts down, which probably isn't what you'd want on a production server. And as I said, for the moment, I've not put in the HTTP payload and encryption because it's really hard to read examples when they're encrypted. And that's it.
Mr. Satinokia, this assumes that the client of the Lurk protocol is the key owner, right? The assumption here is that the client of the Lurk protocol is the key owner, right? When in step 1 or 2, when you create the key, when you request creation of the key.
Yes, the assumption here is that, yes, there are 3 parties logically in this protocol. There's the owner of the key pair, and then there's the authorized user of the key pair. And yes, obviously there has to be an authorization that's given, and quite how you do that, I mean, like, obviously I want to use my mathematical mesh to do that, but obviously it's got to be something that other.
Hi, Frederick Few. I will, this short presentation, I will speak about a CDNI use case for Lurk. So CDNI is a CDN interconnection, and CDN interconnection is addressed in the CDNI working group that specify interfaces for CDN interconnection. Next slide, please. So far, the CDNI working group has specified lots of interfaces.
Actually, so you have it right here, so you don't have to go back and forth. You see the, no, you see the computer? Yeah.
So they have specified a bunch of interfaces for supporting the HTTP delivery delegation. We have several methods for redirecting the end user from an upstream CDN to a downstream CDN in either HTTP or DNS. So now we are, as HTTPS is being generalized, we are now focusing on how to make HTTPS delegation. So in this particular use case, in an upstream CDN will delegate the HTTPS content delivery to a DCDN. But the UCDN doesn't want to provide the DCDN with the private keys, either from the content provider or the UCDN. So that may be for several reasons, particularly legal or security. So using Lurk, the idea is to let the UCDN store the valid certificates and the private key of the content provider or its private keys, whereas the DCDN will rely on security materials that will be received from the UCDN key server. And finally, the DCDN will be able to deliver the content using the HTTP, using the certificate from the UCDN or the content provider. So in this small code flow, we can, that shows how it would work in practice. We can see that the user agent will contact the UCDN to be redirected to the DCDN. So here it is done in DNS. And once the user agent will contact the DCN. So we have the start of a TLS negotiation, but as the DCN doesn't have the private keys, it will query the private, no, not the private keys. It will query the UCDN key server to get the necessary security credentials. So here it would be the signature of ECDHE parameters. Once we get those security materials, then the DCDN is able to make the TLS connection with the user agent, and we are able to deliver the content with the certificate of the content provider. That's all. So for the next step, so this kind of interface is of course common to other use cases. So we should specify it in one. Thank you.
Thank you.
Next, we would like to discuss what we've heard, and I would like to ask people to step up to the mic to try to focus on the problem statement, on whether there is interest in having delegation of private key signing for the CDN/TLS use case, maybe for other cases. So please start with the problem statement, before we dive deeper into the particular solutions.
The lanes are open. There's no danger in coming up to the microphones. Eric? Eric, now's your chance. Where'd Eric go? Philip. Oh, there's Eric.
Yeah, I see.
Philip, who are you?
I'm Paul Hambaker. I'm from Komodo. The way that I see it is, I can see a huge number of use cases for doing some remote key service, the software signing, etc., ones that are described. And how I would say it is there a demand for remote key usage, number one, and second is remote key usage with restrictions for specific applications. In the CDN piece, the real question is, are you going to do restrictions? And if you do restrictions, are they actually going to do what you think? Which is one of the problems that came up. Whether that CDN one is the one that, you know, I don't see it personally.
Well, I'm not taking a position on whether we should do this or not, but it seems like it would be nice before any agreement to do anything is made that it's very clear on what exactly we're trying to do and what it should and should not do. And so in that mind, it seems like, you know, is the point of the CDN, is the point of something else? What are the security properties it's supposed to have? Obviously, it'd be good if we thought we could actually achieve the security properties. You know, it seems like this has gotten into detail, and it's actually nice to see real presentations and understand what people thought they couldn't do. But now I think it's time to step up and ask the question: what would you want to do in an ideal world? We think that's achievable because, and is our common consensus that's what we ought to be doing?
Rich Sauls. Yeah, I agree with Ecker that we need to pop back up and look at what we want to do. I think this, as I said, on CDN, on the mailing list so far, CDN was a dominant use case. To address Phil's question, no, we're not interested. We don't see a need to cryptographically bind what the key can be used for. There are legal agreements between CDN and the party, and so it would be really out of band. And I forgot to mention on the slides, someone pointed out to me in the chat, we've implemented this. We'll use it internally.
Yeah, I'm trying to figure out the trust model in the CDN use case, because the content is usually more valuable, more important than the key. I mean, the key can be no more valuable than the content it protects. So trying to figure out how I can trust the CDN with the content, but then not trust them with the key. So, for example, we use a CDN for distributing software updates. And so we're allowing the CDN to distribute bogus software updates as long as they don't misuse the key. That looks really weird to me.
Rich solves. Yeah, it is. Customers ask for strange things. The other issue, though, that's of interest is, as I alluded to with the hostile country thing, if somebody implements a key escrow, then the cloud provider is not the one that they have to go to. They would have to go back to the original customer. Right? And that's of interest to people like CDNs or others using keys on behalf of someone else.
This is DKG. It seems like there's another issue with a hostile country where they can simply say, okay, fine, just give us access to your, I mean, this would be a mechanism that would be very useful for a hostile country to say, you must implement this mechanism so that we can have access to this quickly to pretend to be you and everything to do. So I think the hostile country argument cuts both ways. I also wanted to ask a question about the software signing use case. I mean, there are many systems where you have some kind of team or group that's authorized to sign a release, and you have developers who can propose a signature but don't have the way to actually make that signature. And the way that's usually done is the developers have their own keys. They sign the version they think is good. They upload it to whatever system is checking on this, and then ultimately decide to make the system. So we have those mechanisms in place already. I mean, I certainly say for the Debian project, individual developers sign packages. Those packages don't make it to the users until they've been signed by the archive signing fee. And that's not any fancy like key delegation. It's just that the folks doing the archive signing decide on the basis of the developer signature. So it seems like extra engineering beyond what we meant.
Eric Nygren, I do want to emphasize, I think what Yoav alluded to, is that there's a big separation between the mechanism here of allowing people who do have things at two different trust levels to be able to separate out the loss of the key versus the protection of the data and look at those two problems as two separate problems from the when is this a good choice to use. Because like software download, unless you have, and if you're doing software download, for example, that is actually a great use case for that. For a download client that has end-to-end integrity checks on, that actually once it downloads the thing, they can verify some signature. It's a totally reasonable, it may be a reasonable choice to say, okay, we'll use TLS as a model against this to give us better performance and provide some degree of privacy, a little bit of privacy to the user in terms of exactly what things getting downloaded, but then we provide the real integrity by validating the signature at the end. So there are some use cases where it is valid. Things like images on a e-commerce website is something where there may be a business reason to why the integrity of it's more important to have those at high performance and over HTTPS than to have them be than to have extremely high integrity for that data. But at the same time, you go to the other extreme, this is probably not the thing you necessarily always want to be using for e-commerce transactions or banking transactions without a lot of other controls in terms of really understanding how both sides of it interface.
So there's clearly a lot of interest in this problem space as we saw earlier before in the mailing list and even here. But I am wondering if the interest is because people are deploying their own solutions already to a problem that is solved in many local spaces. And I am wondering here if we really need to do a standards effort on something like this. Is there an argument for actually standardizing these mechanisms? And I'm just asking this question of the room. I'm not expecting anybody to answer it right now.
You guys are asking this.
Okay, Phil Hambaker, just responding to DKG's point there. Yes, I understand that, well-run software, open source software groups have found ways to solve this problem. But when I'm looking at the problem, I distinguish between two problems. One, functionally, how do we get the signature on the executable that ships? Yes, everybody has solved that problem. And the other one is that solution secure? Now, the Debian guys, yeah, they probably have done it right. The average person, probably not. And so for me, what I'm worried about is the 10% of people who get spearphished and their code ends up their code signing cert ends up signing malware. So, there are a lot of pinheads in this room, in this world, and a lot, there are a lot of pinheads who end up with code signing certs, unfortunately, who end up signing malware, sorry. Yeah. Now, the other question there is, should we standardize? And one of the things I noticed between all the use cases that we're getting, they all seem to me to be very much of a intranet sort of flavor. And very little of them seems to be internet sort of flavor. No CDNs, that is, no, the CDN thing, we're looking at what's happening inside Akamai's gestalt. I'm thinking that that's an intranet thing with two parties. I'm not seeing an end-to-end thing that needs a lot of specification. Sorry.
Yeah. So actually, we actually do have time. Do you mind holding off while these guys flame back, and then we can get to your?
Oh, sure. Yeah.
Okay.
Go ahead.
Yeah, Rich Salt. No, it's one organization talking to another over the public net. It's therefore an internet thing. It's not a multi-party thing. That doesn't make it not internet. I agree with Donna that maybe it's not right to do this. On the other hand, we've seen products out there to do it. I don't go forward or not. I don't have much of a dog in this.
Well, the reason we want to standardize that is that to enable interoperability. For example, you have one ISP that wants to interact with different CDNs. So fair not to have as many libraries as people involved in that.
An ISP. Sorry?
I mean, we don't want to have
You
as
said
many
ISP.
libraries as actors. Sorry. Who I'm answering. So the reason we want to have interoperability is that we don't want to have as many libraries as actors involved, which means content provider, the owner, and the end.
All right. So, Martin Thompson, Eric said something about a couple of use cases for CDNs that sort of made me think, well, why does the CDN need to have my certificate? We talked about hosting images, talked about hosting software downloads. I've seen a lot of CDNs. This is probably a question that Rich can answer easily. I didn't see it in any of the presentations. Is why do you need the keys? Because a lot of CDNs serve content off their own names, and that works very well on the web for a lot of things. What reasons do you?
Because customers want that ED cert green bar.
The top level nav?
Yeah.
But he's talking about loading images and downloads and
No.
all those things that
They want it.
on the top level navs.
No, so okay, sorry, Rich Sauls. I'm not being rude, Martin. No, kinda. Yeah, don't take it personally. There are a bunch of classes of customers. There are some who are just serving quote unquote mass media public content, and they don't really care if it says Akamai Cloudflare CDN on the bottom. And then there are customers, financial, PCI, healthcare.gov or something, which really want to make sure that their cert is what shows across the bar throughout the entire user experience. And those are often more than just EV certs or, EV certs.
You can also imagine a Kyle Rose, by the way. You can also imagine a. Well, no, I'm responding to Martin. So I'm saying that you can. Just real quickly, you can also imagine cert pinning uses here as well, where if you have multi-CDN, you might want to use the same cert across multi-CDNs. That's all.
Ian Sweat, Google. So I think this is certainly interesting. It's pretty clear from hearing around the room that a lot of people are either starting to look at this or have implemented it in various forms. If for only that reason, I think at least talking about standardizing it sounds wise because, as Edgar pointed out, I think there are a lot of ways to screw this up, probably an infinite number of ways. And it's not even clear to me that people who are very professional and probably have done perfectly fine job of it internally. Those solutions are scalable to, the long-term thing. I think it'd be good to refocus on kind of what is the scope of this kind of thing, and try to figure out if we can actually technically meet them.
This is DKG. I think the most interesting proposal that I've heard here, I think, was something that Phil said about possibly doing some kind of key split arrangement where neither of the two parties actually has the secret key entirely. So maybe that's something worth pursuing, but I don't see that in any of the proposed charter goals. But as far as whether any of this is going to prevent some pinhead from being spearfished, it seems to me like if you get spearfished because you have the key, or you get spearfished because you have access to the Lurk backend, you're getting spearfished. So I'm not sure it's all that much.
Mark Nottingham. So it would be a horrible thing if, to interoperate with the CDN, I have to deploy that CDN's version of TLS, the TLS stack on my servers. We're here for interoperability. I think the need for a standard is very real and very obvious because, whilst this is not happening in the sense that it's on the open internet between the endpoints, it's still an interoperability issue and it still involves TLS. To Martin's comment, CDNs in about 2000, state of the art was yes, put it on the CDN host name. That is not really the case anymore for a large variety of reasons, mostly around how the web stack is composed. Having third-party content in the web has a lot of impact on the security model as well as on performance. And best practice now is to try and get everything on the same host name wherever possible. And so I don't think that's a reason to stop this. In terms of other models and doing much more interesting things, I don't hear anyone saying that this is an endpoint that we're going to stop innovating how we think about security and we think about encryption on the web and in TLS. I just think that this is something we need to do and get done so we can continue that evolution.
John Peterson. I think I largely agree that there probably is a need for a standard in this space, but maybe I'm the only one who's still, I think there's a couple different problems actually being discussed in this, and definitely if the problem is the open internet problem, especially the one in CDNI, since CDNI was presented as use case and I participated there a bit, it's largely like a secure redirection problem, which is a little bit different from how I kind of see the traditional player and actually I thought were kind of motivating this. And I do want to make sure, as it gets scoped and as we discuss what's happening on Big I Internet versus not, that I think we distinguish what probably are slightly different problems here being solved by some of the different things we're talking about here that CDNs need to do, and that we get the problem space for this crisply scoped to make sure which of those problems we're solving and what we're
Eric Nygren answering the why would we standardize on this, and I think I echo what Ian was saying in that this is the sort of thing that's going to happen and is already happening, and there's enough different ways to get this wrong, as Rich was talking about earlier, that having at least one version out there that we've actually had discussion on and peer review, that gets it as close to right as you can get it, it's going to be a lot safer in the long run than having lots of different variations on this, some of which have signing oracle vulnerabilities because the person who implemented hadn't really thought through the issues there, while others have been thought through and don't have those issues.
So, Martin Thompson, I want to sort of step back a little bit and think about ocean boiling and the sorts of things we've been talking about. Phil talked about the code signing use case, and we're talking about a bunch of other things, but it seemed like the initial attempts here were very focused on, I want to post a particular name on TLS, and someone else has the keys for me, and that's all I want to achieve. Is that something that we can discuss now and come to some sort of conclusion on, or are we just talking about PKCS 11 RPC? If you want, I can write that down.
Oh, I've got hives now. Or you want bingos? I would offer it's worth discussing the issues of the merits or demerits of having anything more than I want to remotely present my identity, but I don't know that we would decide right now.
Oh, I think this is absolutely the core of the charter discussion that we're having here, is to decide the scope of the problem that we're trying to solve. And if the scope of the problem we're trying to solve is
infinite
PKCS 11 RPC, then we've had a solution, right?
Definitely do it, Martin. I definitely do want us to talk about it, though. That's, I'm not saying we should not be talking about it. You're wrong.
So hats off, whatever hats it may be. Most of the discussion so far has been about CDN, and in my personal opinion, we may be addressing it the wrong way technically, because if I have a lot of content and I want to outsource it to a global CDN, that's because I don't want to have a scalable infrastructure that will be able to sign each and every handshake for the CDN. So what's the next logical step? Since I, the content owner, cannot do it, I will end up giving the private key to the CDN, who will distribute it into some sort of, secure enclaves, secure. And so we're not really solving the cross-organization delegation thing with this solution. We're just making as if we're solving it. And so that's on the negative side. On the positive side, I think ACME and short-term certificates, short-term credentials can offer a solution which will in fact be scalable for this problem. But there's a lot of interest in the room about key signing, and maybe it's time we separated the two things, the CDN use case and signing boxes.
Seems to me that you've got, the reason that you usually limit scope in a working group is to finish quickly. And so usually when you have a smaller scope, it means that you finish quicker. In this case, it's the opposite. As you just said, if you're just doing PKS 11, private key on a stick, we're done pretty much. Like my draft is PKCS 11. So the real question is, do you want to write the charter so that you do private key on a stick and just leave it there? I don't think that that's the case. The other one is, do you want to do private key on a stick for TLS and nothing else? And by the way, we will make sure that you cannot use it for anything else, which is the usual thing that ends up when, and I've been in these BOF discussions where somebody said, oh, we're going to limit scope. And then I'm saying, oh, yes, but, and then we come the working group, I'm saying, but if you do that choice, you're going to cut off all my use cases and so on. Oh, but they're out of scope. And says, yes, but it doesn't mean that you can just arbitrarily kick them out. So the second one, so the choice are PKCS11 only, PKCS11 plus TLS restrictions, or TLS restrictions only. I'd be quite happy with a working group that was chartered to do PKCS11 plus restrictions on key uses, and the only ones that would be considered in the working group in the first round would be for TLS. That would suit my purposes fine, because there are some restrictions that I would want to do, but they're not necessarily algorithms that I would want to discuss right now, or necessarily would need to standardize right now.
Richard Barnes. So, yeah, I thought I was going to disagree with Phil, and then he got around to where I agreed with him. I think in order to address all of the signing oracle issues that have been raised by multiple people, we're going to have this protocol not be a generic give me a remote key protocol. We're going to have to tie it in to use cases. That said, I think there's more to the there's enough of the protocol that's not the signing thing, that it's worth building sort of a framework into which we can plug these different use cases. We can do a TLS 1.2 and 1.3 as a starting point, because we know we're going to need both of those. And maybe that leaves the door open to doing something like code signing in the future. But I think we need to proceed in that structured direction and use that to guide the prioritization of those use cases. I'll comment briefly on a niggling concern about ossification here. This is introducing another entity that has to get upgraded when you upgrade your protocol stack, right? We've actually benefited from the centralization of the web on CDNs lately, because, Akamai, Cloudflare, and the 5 other top CDNs can upgrade their TLS stacks, and the millions of websites around the world don't have to, because we can get a little bit faster agility in TLS stacks that way. We're moving opposite of that direction with this sort of thing, because now all of the Lurk boxes have to get upgraded. But I think that's the trade-off we're going to have to make if we want to have this have a secure protocol here.
John Peterson, just another hit on the scoping question. Yeah, I do think we do tend to scope working groups around things that are hopefully not a set of heterogeneous problems, right? And I mean, we can find a lot of things that have, I think, a superficial resemblance to this problem space. We got this working group called STIR, right? And it's trying to do signatures for telephone number verification on the internet. And it'd be really great if you're in a 3GPP context, if you go to a visiting network, if you'd be able to go back to the home network and get them to sign for you. You want to be use cases that look like this a little bit? There are a ton. There's actually a ton of hard differences, though, I think, in especially again things like secure redirection or delegation necessarily compared to this. So I would prefer finding something that's maybe a little bit more tightly scoped. And if it turns out that that's a pluggable framework that can solve a couple of problems, that's great. But yeah, bounding is better. And I think if there's a consensus to bound things, then it often tends to work out well when we do so.
Yeah, Martin Thompson, since I asked the question, I think I'm going to now answer the question. I think the way that John described it is the way that I'd like to see something like this happen. Having a narrow focus in it and something gives you the ability to cut the corners off that don't suit the other use cases if you absolutely have to, but doesn't say that the working group can't produce a solution that can be used for anything. If it so turns out that it is possible. I just rather state that we are trying to achieve one particular goal and actually hopefully achieve that, rather than try to go off and get encumbered by the baggage of 1,000 use cases.
Jana Iyengar. I also like the narrower scoping and sort of more grounded cases. That said, I will also ask the question, and again, this doesn't have to get answered now, but this is also not a working group forming BOF. So I'm not that worried about trying to figure out exactly what the working group should do. But there should be the question of if this gets taken up as a working group, and if there is work that proceeds in this working group for, let's say, the narrow case of CDNs, then are there CDNs that are willing to go ahead and implement whatever solution comes out of this? Because one of the problems that we suffer in the IETF in general is deployment. If you're taking a solved problem, standardizing it, and nobody else then goes picks up the standard, then we wasted a ton of effort. If on the other hand, what we want to do is document best practices so that folks who are coming forward know how to do this right, then that's again differently scoped. So I'd be careful to just sort of figure out who wants a standard in the space so that we have implementations going forward of the standard, not of your own favorite way of doing this. And if there are many different ways of doing this, then go ahead and do PCPs.
Hi, this is Jim Fenton. At the beginning of this whole thing, part of the use case description was that it was difficult to get some of these people, some of these entities with like EV certificates to actually delegate them to the CDNs and so forth. And I'm wondering if, and it's a completely different direction, I think, from a lot of what we've been talking about here, but is there some way that we can make that a more palatable thing to do, either by, apparently they're like sharing private keys all over the place. Is there something that we can do in order to encourage the generation of much more granular certificates for use by CDNs, so that, and maybe something having to do with making revocation better or something like that? This may be a much longer term thing because it needs to interoperate with current browsers and things like that. But I'm just wondering if there's other approaches that we can do in order to kind of de-risk that risk problem that kind of led to this in the first place.
There was an assertion in there that I'd like to hear from people, vendors or customers. Are people hesitant to hand over their EV certs? Boy, there are 4 people almost standing up. They're like, I don't want to go first.
That's a business secret.
Yeah. So, from my perspective, EV certs aren't special. We don't really do anything too much with them. I get. Oh, they.
Yeah, they're not.
Approximately
This is
the
Rich.
same.
Yeah, they're not to you, but they are to the end user. But they are to the end users of our customers.
Yeah.
Which is, it's like badging.
Yeah, I just don't think in this context we need to be particularly excited about the distinction between OV, EV, DV. None, that doesn't seem to play too much.
Our commercial experience says otherwise.
Okay, good.
Yes, we are all just individuals, not representing our companies, but maybe informed by our corporate experience. Any other discussion before I dive into things that may create some discussion? Let me propose something and see if this doesn't create some discussion. I'm going to ask 2 questions. Yeah, Sean's like, boy, I've heard this a million times. So the 2 questions I'm going to ask, one is in the positive. Do we believe that there is a problem to solve and that the IETF is the right place to solve it? For those of you who have taken logic or computer programming or anything like that, there's that and conjunction there. The other question I'm going to ask is in the negative, which is that you either do not believe that there is a problem to solve or the IETF is not the right place to solve it. Does anyone want to talk about that before I ask those questions? Martin?
Are we asking the question of competency as well? Do we believe that we can solve the problem that we think we have in front of us? Eka asked a bunch of questions about the signing oracle thing, and I don't think we got to the bottom of it.
Well, actually, so I'm glad this is why I did that. Did he leave?
Yeah, he had another meeting.
Can you channel him? Do we want to discuss this a little bit more, explore it a little more?
It seemed to be a desire on the part of some of the speakers that they wanted to avoid having this protocol create a generic signing oracle. And he expressed some skepticism on that point. And Phil expressly said, no, I think you might have said that a signing oracle was kind of the point of some of this. So we need to address that question.
I think that what Eka was reacting to there was a presentation that asserted that they had achieved a restriction. And he was saying that, no, you haven't actually done that. I think that there are three separate possible scopes. One is unrestricted use of a private key remotely. So you just treat it, PKCS11 or private key on a stick, whatever. Number two is remote use of that key with restrictions specifically for TLS and possibly specifically for TLS 1.2 and even further. And then third would be private key on a stick with restrictions for any application that anybody wants to drag in here and discuss. Now, in terms of how difficult it is to do the work, the first one is really easy. In fact, we could even go home and say that we've done it. The second one obviously needs a lot of work that I think can only be done here in IETF because you need to understand the internals of TLS. And then the third one is, well, you don't want to do that because that's going to be a
signing oracle.
But from my point of view, I want that ability to do the unrestricted oracle with the ability to declare optionally restrictions that may be defined in another place. Because if Oasis are designing a spec, they may be the place to describe the restrictions for that particular protocol. So the question is, are you going to design something that is only going to be usable for TLS? And anytime somebody says, I'd like to use it for other things, are you going to kick them in the butt? Or are we going to do a generic platform and only consider applying that platform to one use case? And there's a big difference.
Ted?
Ted Hardy. So I think I heard the answer eventually, but I think it's not exactly the answer that was being given earlier. So let me go back to the very beginning and Rich's presentation, where the problem statement included does not become a generic signing oracle. And refer back to Ecker's statement, which I believe is true, that because there is a great deal of capability in what some people are calling the edge server, in claiming what it was asked to negotiate with the client, what it ends up sending to the key server is, essentially speaking, some number of bits for signature, 256 plus 64, for example. If that is the case, you have a generic signing oracle for that number of bits functionally. If that is a desired property, then you need to have a hum in this room that takes away that previously desired, does not become a generic signing oracle from the set of goals of the problem statement. So I think that having clarity on that point would be a very useful outcome of a bomb.
So actually, I will take a chair's prerogative and do this the way the chair can do it. Hum if you read Daniel's draft in particular. Okay, so it's a modest number of hums because, and the reason why I ask that is Daniel's draft in particular, although a lot of the mechanisms probably wouldn't, are like contractual, there were also a lot of mechanisms that were protocol-wise. In other words, he did think about it, and I would think that the working group would think about it. So I just want to make sure that people who are saying we don't want to be a signing oracle are looking at this from, it would be okay to say, yeah, I looked at what he said and it's crap, as opposed to, oh gosh, you guys haven't thought of it, because a number of the drafts do at least attempt to start to address that issue. And this better be a direct answer, otherwise I'll send you to the back of the line.
It's just a correction of what Ted said.
Okay.
The signing oracle statement was made in our protocol proposal, not in the problem statement.
Kyle Rose. So one of the things that Ecker said to me was that it was more about the complexity of the protocol not achieving the objectives. So basically, you built this complex protocol that you claim is not a full signing oracle, but in fact it is. Like the complexity that you built in doesn't actually prevent it from doing that. And that's one of the things that I wanted to ask about Phil's design, and I have to look more at what he's done. But what the restrictions, so there, early on in your presentation, you had something about usage restrictions. Basically, you could say restricted to TLS 1.1 or 1.2 or something like that. How is that actually enforced? Like, what's the mechanism for enforcing that? In such a way that it isn't a generic signing oracle.
Okay, so the idea of the IONA registry would be that they would be, you would describe a particular, restricting the key to a particular set of key protocol uses that would constrain you. Okay, so I'm not, so it could be Daniel's methods and Richard's methods would slot in there, but they would both have their own unique identifier because they're both constrain the key in different ways.
I think what I'm asking is, so when you send some data into a signing oracle, you get a signature out, and it's just a sequence of bytes. How do you distinguish that sequence of bytes from a signature for a different version of the protocol? Right. So I mean, because the user, the edge server in this case, could lie about what they want to use it for.
Yeah. My protocol is separated into two parts. One, there is the mechanism for how you talk to the service. And the second is when the service receives a request, what types of requests will it accept for that particular key? Those are set when the key are created. And you've got a vocabulary there that you can define multiple ones of. So you might have rich socks be one of the types. And that would specify exactly how you do that. And and that particular mechanism would be saying, I am not going to provide a signing oracle, and here's how I do that. So
right, the output has to be restricted in some way that prevents you from reusing that output for some other purpose, right?
Right, and I'm saying that in my protocol, that is a requirement that's incumbent on the person who is designing that restriction, and not on my part of the protocol.
Okay, so I mean that sounds more like it's placing a constraint on TLS, for instance, like the design of TLS.
Yeah, I mean at the end of the day, any constraints that you have from the service point of view, those have to be rendered into code that says thou shalt make sure that you take in this data, you process it in this particular way, and then you produce an output. So I've not looked into the TLS specification in detail with a view to looking at this particular problem. I suspect that there are many games that you can play with nonces and how those are constructed.
Or labels, say, in HKDF expand or something like that.
Yeah, and the point is that in my proposal, I'm giving you a vocabulary so that you say when you create a key, which of those you're going to permit. And optionally, I guess the administrator could change it later on.
Okay, I feel like this is now in the realm of now we need changes to TLS in order to use it. I'm not sure. I haven't.
Let me just interject. Even if doing this stuff for TLS 1.1 or 1.2 is hard or impossible, we're still in the position where we can influence 1.3 if that's required.
And it might well be that your design, an acceptable outcome might well be, we end up with something that turns out to be an unrestricted oracle for 1.2 and below. But if you're doing 1.3, we've designed that key exchange in such a way that we can enable this. Yeah. And then that would be an argument for bringing that work here and for focusing on that particular restriction case. But it's the restrictions that's the hard part. The other protocol piece, I mean,
This is Daniel Kahn-Gilmore. I would be very sad if TLS 1.3 blocked on the resolution of this process. And I do think that it's important that if we're talking about scope for this this question that we're addressing here, that are we okay with something that would require modifications to the protocol? So things that would not interoperate with existing clients. Right? Is it useful for, say, the CDN case to produce something that says, well, this is only going to work for keys for TLS 1.4?
So, Stephen Farrell, I mean, I guess I can help it. So, if this is going to require changes to TLS, it's not even going to start until TLS 1.3 is finished.
That's where 1.4 comes from.
Sorry?
That's where 1.4 comes from, is the point.
Eric Nygren. Yeah, I think in the short term, anything that requires changes to TLS protocol isn't really useful for a lot of the ways people would actually want to use this to deploy it today. On the other hand, it's probably worth us taking a brief look on the TLS 1.3 side in terms of the context labels we already have as part of the signatures, just to see where the ordering of those might want to put those, because many of the same things that are useful here are probably also useful for HSMs that also want to prevent themselves from being a generic signing oracle. And there's a bunch of these cases where you do want to separate out the HSM, excuse me, the security module functionality from the thing that's actually terminating connections, and being able to split out some of the context label stuff there may be generally useful for those cases in the longer term.
Yeah. So Martin Thompson, we've already done work on this thing in TLS, and if we've done a bad job, let us know. But let us know pretty soon. But my point was to the client modification thing. I think if we're going to require any changes on clients, period, I think there's a good chance that this is the worst solution ever to that problem. And if you proceed down that path, I think I'm not interested in being involved, and I might be interested in destroying it in every way that I can possible. Because I think that if you're willing to make changes on clients and your goal is to show your customer's EV cert in the browser, we can have that happen in other ways that don't stink nearly so much.
So Eric Berger in the audience. So this is an interesting turn of events, because I kept asking, why are we talking about how to do RSA, static RSA? Why are we talking about anything but perfect forward security? And I got a chorus of, because we can't change any of the browsers. So I just want to kind of, so that's why I'm saying it out here, because it was just my question. And I was almost convinced by people, oh, no, we can't change the browser, can't change the browser, can't change the browser. So I just want to make sure either I've missed something and you've seen something that, set off an alarm bell, oh my goodness, I'm going to have to change all the browsers, or we're just concerned that we might go to that place and that maybe it's even a charter thing to say we're not going to change the browsers.
I thought this was an operating assumption. Can't change enough of the browsers for this to matter.
Yeah, Phil Humbeck again. I'm just rethinking, why do we actually care about the signing oracle case? How many people use their TLS cert that they use on their server for other things? Can't we just tell people, if you're going to play this game, don't use your certificate for other things?
The problem with the signing, Phil.
When we create a certificate, we put in OIDs that say what the permitted key uses are. If you go outside those uses, you're nuts. And the other thing is that when we go to the elliptic curve crypto suites, there are ways that we can make sure that the key that the user is using is not one that they're using for anything else. And I presented that at the CFRG in Prague, was it, or whatever? So there are other ways that we could solve that problem. Given that it is a hard problem, it might be one that the group would want to move punt on. I need to see a use case in which not that signing oracle makes a difference. I know it's bad for crypto purposes, but
It's not the extra things you use the cert for that are the problem. It's the extra things that the attacker uses the cert for that are the problems. And yes, you can say EKU should be constraining that, but in practice, how many certs have as many EKUs as possible because, hey, I might just need to use them one day? You work for Komodo. How many? Like how many certs does Komodo issue that have the signing and encryption and decryption bits set? Do you offer your customers a chance to get a cert that has just decryption or just signing?
I suspect that it is probably easier for us to fix our backend and produce certs for this particular use case than for getting a consensus on a constraint mechanism involving heavy crypto.
Right, so the constraint mechanisms aren't working today, which is why we don't want to release signing oracle.
Kyle Rose. So even if we do want to produce a signing oracle, I think part of the, I think one of the things that we should take as a given going into that is not to introduce complexity where it's not actually going to have an effect, right? So if you can put in usage restrictions that are, cryptographically strong in some way, then I think that that's worth doing. But if you can't actually prove that the restrictions you're putting in place are actually going to restrict other uses of that signing oracle, then what's the point in adding all that complexity?
And to give a specific example on the Oracle case, it's not just the signing oracle, it's the signing and decryption oracle, because there's still enough clients out there that only support static RSA that to do the not change the client, you're going to have to support doing static RSA, which means doing decryption, and that means that this, if you have that decryption oracle, you basically lose forward secrecy on all the client sessions that are out there. So if you can basically compromise the machine, you can go and take some client session, you sniffed on the wire in one place, replay enough of the stuff against the key server, and now you can go decrypt that session. Whereas if you structure the protocol properly, then you can only do it by an attack sessions when you're actually actively doing it, rather than losing forward secrecy on previously captured sessions. That's just kind of as one example.
Just one thing about the presentation I had. What we did is that we presented the different options without any changes to the TLS client or the TLS server, and we said, well, if we have some choice, there are some things we recommend. So I think we saw the decryption oracle with RSA, just removing the premaster. We didn't solve the issue with the signing, but is that something that we have to solve? And if we have to solve, what can we change? I think that's going to be the next question.
Quick. Yeah, so just quickly, Martin Thompson. I don't think we need to solve the problems here. We have to understand enough of the problems to understand that we can solve them. And I'm not making any statements to that. I think that chairs might want to talk to that soon.
If we can or if we can't.
Okay, so perfect. You're about to hear my timer go off saying it's time to start asking questions. So we're right on time. So and I'm glad we had that discussion because I think it will get us to where we can answer the question. So I will actually still ask the same question, but we'll expand upon it. So in the positive, is there a problem here to solve? And is the IETF the right place? The right place includes that the IETF has the competencies for it. And in the negative is you don't think that there is either you don't think there is a problem to solve, or the IETF is not the right place. So with those being your two options, first the positive option, IETF right place, and there is a problem to solve. Jana?
Question. Does it matter if you all think there are different problems to solve?
If there's,
I mean,
yeah.
it's okay.
Yeah, there are lots of questions. So the positive one, there is a problem to solve, and the IETF is the right place to solve it. And Pete walks out. And Pete does the work. No. So problem to solve, IETF right place, hum please. And 2 more from everyone. Or there is not a problem to solve, or the IETF is not the right place to solve it. So it's actually good to hear that it's not unanimous, but I think I could confidently say that there was a capability there. So something that's specific to this, and this is something we just want to get a temperature on, which is, and the 2 questions will be CDN use case only, make Phillips head explode as a side benefit or drawback, depending if you're sitting right next to him. Right.
Summarize the previous hum.
Well, this previous, well, I thought I had that, but just to make sure for the note tape, here's the previous hum, and so we have it in the audio record in case they're asleep. The previous hum was that there is a problem to solve, the IETF is the right place. There were a few hums that it might not be, but I think the consensus there was roughly there. So then for the next one, CDN use case only, more than CDN use case. Okay. That's a good point. Well, you had like 3. Yeah. Yeah. Everyone just wants to see Phillips' head explode. I know. That's right.
The three options, in my view, are: do you just do PKCS 11? Do you do PKCS 11 with restrictions just for CDNs? Or do you do PKCS 11 with restrictions for anything else that people want to bring in? And those are 3 really distinct cases, because if you're lumping together the 2 outer cases, which are the simplest to solve and the very hardest to solve, which doesn't make a lot of sense.
Stephen,
so I'm going to disagree with Phil. I still would like to know, is the CDN thing what people are interested in working on, or is there more?
Actually, we'll have it if we rephrase it that way, and kind of like that. The CDN only, or CDN and more. That doesn't necessarily mean boil the ocean. Remember, we are going to be crafting a charter, hopefully by Berlin. So again, this was not a charter forming buff. But just to get a sense of, are people like just obsessed with only the CDN case, or considering others? Eric?
And it may be worth thinking of it as a TLS case rather than the CDN case, because I think there are other TLS use cases beyond just CDNs.
Okay, so one more time after Adrian, Stephen says.
I think we should be concerned with practicality here. As a first cut, it doesn't have to be the last cut. I'm interested to know, are there people other than CDNs who want to do this?
Actually, that's a good point. So bowing down to the area director really would like to know, but before he gets the...
So, sorry, I'm going to make it more complicated, or I'm going to try and make it more complicated than that. So that's another 3-state, right? Is there energy to do CDN at first? Is there energy to do CDN at first plus the desire to clamp it down so that it's CDN only in order to keep it scoped, which then has effects on the utility in the future, or desire to keep the scope open and energy to work on things other than CDNs?
I will defer to my area director, my master, and...
So I just want to make sure that
one question. Okay. We can ask more questions, but let's get the first one out of the way.
Defer to the area director.
That's right. So, actually, Stephen, though, I'm going to ask it strangely, and there's no reason. I will delegate the question asking to our esteemed area director.
won't repeat what I normally say when people say esteemed. Okay, so I'm interested to know, is there energy and motivation and interest only to work on the CDN use case, or is there energy and interest to work on more than just the CDN use case?
Okay, CDN, more than CDN. Hum for CDN. More than CDN.
So I heard a little bit more, but a significant number of just CDN.
Yeah, so significant number of CDN, which tells us we really need to work on the CDN use case, and even more people saying maybe more, which means we should keep an open mind.
Thank you.
Thank you. So that was a summary there. So now I am going to take hands, but I'm not going to name names, but I just want to get a count. Who's going to write drafts? And there's about, I can't count. There's about 7. Okay. Who's going to review drafts? Yeah, call it about 15 or 20. Hum. Who's going to follow the work? Okay, so the tour there, we got just the right amount of tourists in here. Okay, so the next one, this is a hum. This will be a fun one. The scope is well defined and understood. Thank you very much. Yeah, so I think, I mean, those are the real questions we needed to know. Again, you know, I'm pretty confident, we're confident that, you know, we'll be able to hammer something together for Berlin, for you to really dig your teeth in. Yeah, oh, that's good. Yes. Do we think that we're going to need a second BOF to go through this, so that we have energy and interest to get this done prior to Berlin? So prior to Berlin, or do it again? Martin?
Yes, we need to do this again. There was enough confusion in this room now that I don't believe there's any hope that that confusion will evaporate magically.
We have 8 minutes.
Without some more discussion, and I don't see that happening on the list.
Yeah, this is not just a question of like hammering out some wordsmithing in charter on the list, especially because we've had no charter discussion today. So I think we do need to have this intensive discussion again.
Yeah, Rich Sauls, I agree. More time.
I was going to say that maybe if the people who made presentations got together sometime this week, we could work out what the differences are and whether we could come to one framework that would meet all our needs and so on. And maybe there's work that could happen between now and Berlin that might obviate the need for a BOF, and if that happens, then that happens, and otherwise it doesn't.
Okay, Jana?
I agree that there should be another BOF, and not just because there's confusion, also because I think you need to ask for more than just people who are willing to write drafts. You want people to actually deploy the stuff that comes out of this working group.
Okay, so that's fine. Thank you. We got the information that we need. Thank you for your time here. Thank you for our note takers and Jabber scribes, and we will see you in Berlin. Thank you. Thank you. Rats, I was hoping that someone would stand up and say, I've solved it this way. This is all you have to do. You can go home. And I would say, great.
Yeah, well, thank you both. So
And I really think we can insert a label into TLS 1.3 that will make it a non-generic Oracle. It's not such a big deal.
So I think TLS, I mean, they're already adding labels to nearly every signature.
So we're fine then.
Maybe already fine, or just to quibble with what you said, I think, hey, TLS Working Group can inject the label.
Yeah, of course, that's obvious. Okay, fine. Well, I'm not so sure about that.
Labels, IANA expert review, or is it work group only, or is it?
Oh no, they're hard coding. This is a signature in this part of the handshake. Yeah. It's never going to do business. Okay. Into every signature of that. Where the blue sheet? I think they after they
Yeah, well, the thing that I was thinking of saying, but let's not rub it in, is it's